Hello, everybody, and welcome. Today I have Will Toor on. So, Will, tell everybody who you are and what your job entails.
Yeah, my name is Will Toor, and I'm the Executive Director of the Colorado Energy Office, which is a non-regulatory office of the state that is housed within the governor's office and really helps to coordinate the state's overall policy framework on clean energy and reducing greenhouse gas emissions.
All right. And you have this Colorado 2040 plan. What all went into creating it, the planning it, the bringing the people together and everything, deciding what it should be?
Yeah, well, I should probably clarify. We do not have a Colorado 2040 plan. We I think you're referring to a study that the Energy Office conducted that looked at a number of potential scenarios for 2040. What we actually have in place today are a series of plans that are focused on 2030, where
Okay.
through legislation that was passed in 2019 that set a technology neutral emission standard for our electric utilities. So the way that it's structured is our electric utilities have to develop clean energy plans that will achieve at least an 80% emission reduction by 2030 compared to a 2005 baseline. And it's really up to them, what is the mixture of technologies that they propose to do that. For the smaller utilities in the state that aren't regulated by the Public Utilities Commission, so our municipal utilities and some of the independent rural cooperatives, they really just make the decisions through their own utility boards, and the state's role is just verifying that the plans actually meet those emissions requirements. And then for our larger utilities, really primarily Xcel Energy and then Tri-State Generation and Transmission, their plans are approved by the Public Utilities Commission. So there is a PUC review that is really looking, primarily at ensuring that the plans meet reliability requirements and that looking at the costs and trying to make sure that within the constraints of reliability and emissions that are minimizing cost to ratepayers. So that's the planning framework. And so the plans that are in place right now are those clean energy plans and electric resource plans that have been adopted by the various utilities and that are
Okay.
generally
And
built around 2030.
question on that. So I know in some of the plans they use the word renewables, and in other plans they say reduce CO2 emissions. And the giant difference between that two is whether or not nuclear falls into it. So, under the stuff you just talked about, is nuclear an acceptable answer to it?
Yes, so the state planning framework is basically technology agnostic. It,
Okay.
it allows for the PUC regulated utilities, the PUC can consider essentially any technology that is low or zero emissions as a clean energy resource that helps
Okay.
achieve those targets. That certainly includes renewables, but it also would include either conventional or advanced nuclear. It would include geothermal. It would include gas with carbon capture. And in fact, that's the one thing that to date is really moving forward at scale is that the Tri-State in their electric resource plan has included gas with carbon capture as one of the resources. And it would also include hydrogen. It's essentially a very broad, again, technology agnostic planning framework.
All right. Let's shoot into both Colorado law and the 2040 plan. The 2040 plan did not list nuclear fission as it exists today. It mentioned in passing SMRs, which will hopefully happen in 5 to 10 years and won't be as efficient by definition as the big plants. And the Colorado law, as I understand it, says renewables and explicitly does not include nuclear for achieving no carbon
Yeah, no,
output.
so
So
that
what's
that's
going on with that?
yeah, so that's not actually accurate. And maybe to give a little bit of history here, because this may be sort of where there, I think, is a bit of a disconnect. Back in 2004, the voters of Colorado did create a renewable portfolio standard that required
Hmm.
utilities to achieve 10% renewables by 2020. and in the years after that, between like 2006 and 2010, that was increased to up to 30%. So
Mm-hmm.
that is technically a requirement. All of the utilities have exceeded that requirement, and it has essentially zero impact today. So the new planning framework that was put in place in 2019 was this technology neutral emission standard. Under that standard, there's no, it's simply a requirement that utilities need to plan to meet this 80% emission reduction by 2030. And
Mm-hmm.
there's no sort of picking and choosing among those technologies. So any utility that wished to could bring forward a, nuclear as part of that. To date, none of them have. Again, the only sort of clean, firm proposal at scale that has been brought forward and it was approved was Tri-State's proposal for gas with carbon capture, but there would be nothing precluding any utility from bringing nuclear forward.
Then why is there a law being proposed in this legislative session to change that renewable requirement to include nuclear?
So that law basically would have almost zero impact. It's I think, a symbolic statement that is probably being considered sort of as a symbolic statement in support of nuclear. It doesn't actually change what's known as Title 40, which is our utility code. In fact,
So, sorry to interrupt, but that means the utilities today could build, let's say, 6 nuclear plants and then tear down every windmill and they would be okay.
well, with the caveat that they need to show that what they're doing makes financial sense. So from an emission,
Assume for a moment that windmills make no financial sense. You don't have to agree with it. Just assume for a moment that they're just a cost center and there's no savings anywhere. Is there anything in the Colorado law that stops them from evolving to nuclear across the board and let the windmills run until they hit their 10-year end of life and then just tear them down and they all go away?
so
And so you're then at, what, 80, 90% nuclear?
well, I think there would be multiple practical challenges.
But the law would be
But there's
okay
no
with that, you're
legal
saying?
there's no legal constraint to utilities bringing forward nuclear or any other zero emission form of generation as part of their plans. For the large
So
utilities,
that law that they failed the 2 past sessions and they're bringing up again this session is just a total waste of time?
I
Makes
would
no
say
difference?
it's primarily symbolic. I
Okay.
think it's a symbolic statement of support for nuclear. The only practical implication that it would have is not actually in the realm of what can be approved by our Public Utilities Commission, but it would change a statute that allows county governments to issue a form of financing, what are known as private activity bonds, to support clean energy projects. To the best of my knowledge, I'm not sure whether any counties have actually used
Okay.
that authority, but it would extend that to nuclear. Because of the fact that the actual allocation of private activity bonds that is available to county governments is relatively low, the chance of that being enough financing to make a difference on something of the scale of a nuclear power plant is probably not, it probably doesn't have a significant practical impact, but
Okay.
that is the one substantive change as opposed to a symbolic change in that piece of
Gotcha.
legislation. And I would note that at this point, the administration has not yet taken a position on that legislation.
All right, so let's go through wind energy. I'm assuming you read my stuff about how wind energy, if it's backed up by gas for when it hits its doldrums, it actually, in total, the combined system emits the same or more CO2. And are you familiar with what's hitting Germany with what they call the Dunkelflaute, where there was just a week of no wind and energy prices shot up to 50 times and Sweden and Norway threatened to drop off the grid from Germany?
We're certainly very
We
familiar.
avoid that.
We're very familiar with the concept of the dark doldrums.
Yeah.
And you first would say that I completely disagree with your statement about wind, as does the National Renewable Energy Lab, essentially all utility planners that I'm aware of, and the vast
Wait,
majority of
hold
the
on a
academic
second.
literature.
Yeah, every single one of those guys goes, wind is great, it gives us this energy, and none of them talk about the fact of, and when the wind dies, what are you using?
That's incorrect. So there's an extensive academic literature on this, and I'd be happy to share some of it.
Please do, because
So
I have not seen that.
wind is essentially a resource that would displace the generation that is on the margin. And depending on the nature of the particular grid, there's a variety of resources that could be displaced. In some cases, there would be periods where you ended up running combined cycle gas turbines at a lower efficiency than they would be running if they were running during steadily more as baseload power, and instead they are functioning as partially as backup to wind. What the academic literature has suggested when they've modeled the impact on sort of real world grids is that depending on the nature of the grid, it does have some impact in terms of reducing the emissions reductions associated with the wind. So if without that efficiency reduction on the gas side, you were reducing by, say, 100 units, you might end up reducing more by 75 to 80% in a number of real world grids that have been simulated. But it becomes less and less relevant as you move to a higher and higher renewable penetration that includes wind, solar, and batteries, because you've got wind being produced over a larger geographic area. You've got solar that certainly in Colorado, you tend to get more wind at night, obviously more solar during the day. And as you get more and more batteries out there, you're able to smooth out many of those hourly fluctuations. So, you still need to have the gas there for backup. And certainly it is true that there are times when there could be 2 weeks where you're just running the grid almost solely on gas. But averaged over the course of the year, the amount of gas that is required goes down significantly over time.
Well, correct me if I'm wrong. The wind generators are basically operating the equivalent of 35% of the time at 100%. So 2/3 of the time you've got gas in there, and sometimes more, sometimes less.
Except that
and in
you're
Ireland,
you're not running. But that's not the way that utility systems work, right? It's an entire system of resources working together. You have wind running, as you said, 35% capacity factor is a pretty good average. You've got solar that is also operating.
Solar's great. I mean, it's cyclical day by night and day, but it's great.
But the solar and wind are complementary resources. So in Colorado, and this is something that is particularly true for Colorado, New Mexico, and Texas, as some of the only areas in the country that have really good wind and solar resources, that they're very much complementary resources, where if you map out the time of day of maximum solar production and the time of day of maximum wind production, there's some overlap, but they're largely complementary. You then add in the increasing penetration of batteries, and that system as a whole has a capacity factor that is far higher than the capacity factor of either wind by itself or solar by itself.
All right, so I'm bringing up, this is EIA, so it's the government, okay? Last September in Colorado. So we've got wind with some several day-long doldrums and just incredibly irregular. Now, solar's great. Look at that. Not the same every day, but it's great. And you'll notice then that natural gas is essentially the opposite of wind. And even coal, and you want to talk about horrible emissions, when you move coal up and down, it's just awful.
Well,
but you're saying they complement each other.
The coal's all going away. So
coal should, yeah.
Yeah.
And we're going there. But looking at wind, That's not complementary to solar, and that's got serious multi-day downtimes. So I don't see how on that you say not a problem. Wind is going to be there regularly enough, often enough
Well,
that
because
we're okay.
we've been deploying wind for 20 years in Colorado. So
Right.
over the last 20 years, we've gone from a system that was approximately 70% coal, with most of the rest being gas, to a system that's about 40% renewables, about 30% coal, and about 30% gas. The vast majority of those renewables have been wind. Rather, over the last
Right.
few years, we've started to see a significant ramp up in solar, but wind was sort of the more earlier deployed resource. And during that time period, we've very successfully managed the grid in Colorado. We have maintained Colorado electricity prices that are below the national average and have consistently, through the last report a year ago, the
Right.
Citizens
But
Utility
but
Board been in the top 5 states for lowest energy cost burden per residential customer. So, and we've seen dramatic reductions in the emissions on the grid. But again, the way
but
that
here's the
this
thing:
works is we don't.
you add one wind turbine, and has essentially no impact. You know, it gives us some electricity. It's great. There's no concerns, right? You add a second, you add a third. You're okay. You hit a point where arguably Colorado's about to be there, where you increase it just another 5 or 10%, and we're then in the Duncan Flate. We're then in these where when it dives like that, if 5% of our generation dives like that, who cares? If 30% dives and other states around us have their act together, we're okay. But Germany, Netherlands, England, Ireland have gotten to the point where it just crashes them. You've got California has gotten to the point that they got the highest electricity prices in the lower 48 because they've gotten so much on renewables. Inconsistency, it's the intermittency. And I think you yourself would admit if we were at 90% wind, we would be hosed when we hit those short times.
And nobody would suggest that we should have a grid that is 90% wind.
Right. But what do we do when we add another 5% or 10%?
So,
I mean, right now, wind is no savings on CO2 because that gas and
so
coal
that's
is the
just
backup
incorrect.
for it.
So you can say that, but that is not what the academic literature, the national labs, or the actual modeling of individual utility ERP shows. So
Yeah,
it's just,
get me a
it is
study
not
that
true.
shows that. Combined cycle natural gas is like 66% efficient. Single cycle is about 35%. Your backup, by and large, needs to be single cycle because what Ireland had the idea of, well, combined cycle is better, let's use that for the backup. But they found spinning combined cycle up and back down was actually worse than single cycle because it's not
Yeah.
designed for that.
Yeah. Again, I'm happy to share some of the academic literature on this because it
Please
simply
do
is
because
not
I
true
put
that for
out the
integrated
numbers.
utility systems that wind increases emissions. It just is that is not the case.
Get that to me because I actually put numbers I ran up on the wind turbine group on Reddit, and I had a large number of people that were not happy with me. I had one person found a mistake in my numbers, and I did correct for that, but it didn't change the fact that your CO2 emissions were greater with wind than without. But if you go to batteries, then you go everything's wonderful. But correct me if I'm wrong. Colorado uses an average of 6.25 gigawatts per hour. I mean, that is an average peak winter peak, summer, blah, blah, blah. So, we're going rough numbers. Summer it would be higher, winter would be lower. And you're looking at 60 million for a gigawatt hour of batteries. And so that means if you want to have enough batteries for 2 days of backup for the state, say you're at 95% renewables, you're talking 18 billion.
So
And then those
nobody would be suggesting that we use batteries for certainly lithium ion batteries for multi-day backup. Batteries are used primarily for diurnal fluctuations. You're looking at
well, yeah,
essentially
for the duck
smoothing
curve
things
on
out over
solar, which
periods
makes
of a few
sense.
hours. And
So what would you use for your backup?
so the current plans in Colorado. So if you look at what the utilities are actually doing, they
Mm-hmm.
are generally adding significant amounts of wind, solar, and batteries. they're retiring their coal generation, and they are maintaining and to some extent expanding natural gas generation as a backup. So you have to have the gas generation there.
Okay.
There are times when the grid completely depends upon it. Averaged over the course of the year, the actual use of that gas generation will be going down over time, but it is absolutely essential for reliability. In order
What would
to
cause
get
it to
all the
go
way to
down over
zero
time?
emissions, that would ultimately need to be replaced with other forms of zero carbon firm generation, which could be, again, could be nuclear, could be geothermal, could be hydrogen. I think there's multiple technologies that ultimately will play a role there. But in the near term, it's gas generation.
The best description I heard about hydrogen, I have a degree in physics, so my background comes in there, but the best description I heard from hydrogen is it's an insult to the laws of thermodynamics. Fusion we may get someday. Green hydrogen, I just don't see how the laws of physics will ever make it sensible.
Well, it depends what you're using it for. So if you're essentially
Granted,
using
if
it
you
as,
had some need for something where it was very tight need on something that there was great value in giving it there. A rocket. I don't think a rocket will ever run on hydrogen.
well, the way,
But a rocket would make sense.
so again, it depends on what the level of hydrogen consumption that would be needed in order to provide stability on a grid.
Mm-hmm.
Again, if you look at the modeling that we've done in 2040, it suggests that you need some form of firm generation or firm generation combined with long-term storage that can provide essentially 100% of your energy need. But that the actual energy, so you need a lot of capacity, but you don't need that much energy because as you're building out more renewables and putting more batteries out there, there's less and less actual energy needed from these other sources, but they're absolutely essential for capacity. If it ends up that there's only a few percent of the energy that actually has to come, say, from hydrogen, sort of the economics makes much more sense. If you were having to provide 20 or 30% of your energy from that firm generation, I would agree hydrogen would make very little sense. But in any case, we don't have to make those decisions
Hydrogen, I
today.
think we should talk about because, I mean, fusion, I don't think is happening in the next 20 years. Hydrogen, I just don't think that could be a whole other thing there.
And we are not one of the things that is probably worth sort of making clear is we're not trying to sort of pick winners among hydrogen, geothermal, gaseous carbon capture, nuclear. Rather, our structure to date has been technologically agnostic emission standard, and then allowing the utilities to propose the technologies that they think make sense for their system. And that certainly includes these sort of forward-looking technologies where there's a lot of uncertainty about ultimately what their costs are going to be. And so from our perspective, we think that the electric resource planning process where you're actually going out to like competitive bid processes as part of that and getting real world prices is the appropriate process for essentially picking and choosing among those technologies based upon what turns out to be deployable and affordable. And we think that's the sort of right approach going forward.
All right, and so coal's going out, which I'll agree is wonderful. You'll bring in additional gas plants to replace that coal when needed. And we'll have a system that fundamentally, if the wind dies and we're totally overcast and we're then on the little bit of hydro we have in this state, and then all natural gas, we've then essentially paid for two duplicative electrical generation systems. Do you think the voters are going to be good with the fact that their electrical bills are paying for twice, all the generating capacity 2 times over, and the costs that go along with that?
So when you look at the cost of the electrical system, there's a lot of pieces to that. Certainly capital cost is one piece. Fuel costs and maintenance are another really big part of it.
Oh, yeah.
And
And those go down. I agree with you on that.
And so So
And then you have all the
what
employees
matters
that
is the
work at the
total
plants.
system cost. And because wind and solar are so cheap per kilowatt hour compared to other sources of electricity, what we have seen is that they are very cost competitive. So that, again, the planning framework that we use is there's an emissions constraint. Utilities bring forth portfolios of proposed resources. The Public Utilities Commission is then looking at essentially what is the lowest cost mixture of resources that can meet the reliability requirements and the emissions constraints. And what we have seen that is that in practice to date, based on the plans that have been brought forward and evaluated, retiring coal generation, replacing it primarily with wind and solar, and using gas as backup has been the most cost-effective approach to doing that.
All right, and so I guess you'd say the install and the runtime cost of wind and solar is less than the cost of buying the gas for the gas plants.
Essentially.
Okay, because yeah, you're right, there's three parts. There's the capital expenditure, there's the employees running those things and maintaining them, but then there's actually the cost of the natural gas, which a while ago was incredibly low. It's come back up a bit, so that trade-off will bounce.
Yeah. Hey, I'm going to need to run in a couple of
I
minutes.
give you the last 5 minutes or 3 minutes, however much you got. Give us your closing statement.
Yeah, so I think I would end by saying that I think that Colorado has been on a very positive trajectory when it comes to our electrical generating system. That as I noted, we have a planning framework that's built around achieving 80% emission reduction by 2030 while keeping electricity affordable and reliable. What we're actually seeing is that utilities have been able to move faster than that, and we're on a pathway to about an 85% reduction in greenhouse gas emissions and a very large reduction in localized air pollutants like nitrogen oxide that contributes to our ozone problems in the Front Range, all by 2030. And that we've been able to do this while keeping electricity prices, again, below the national average and the per capita energy cost burden typically in the top 5 lowest states in the country. So a lot of work still to do, and I think there's a lot of challenges moving forward as we move to higher electrical demand, whether it's for data centers or heat pumps or electric vehicles. There's a lot of work to do there. There are certainly costs that are going to need to be managed as we confront underinvestment in our electric distribution system and the need to make investments to support reducing wildfire threats. So there's a lot of work to do, but I think we're headed in a good direction.
All right. Thank you very much.
Thank
Have a
you.
good day.
Bye.